Children, we will be discussing about naming of the organic compounds today and also different kinds of homologous series. The naming of the organic compounds is done by an organization known as IUPAC, International Union of Pure and Applied Chemistry, so that the names of the organic compounds throughout the world are similar. For that, we need to know about the word root, in which the carbon compounds having one carbon will have the word root meth, then 2 carbons eth, 3 carbon prop, 4 carbon bute. This is not but, it is bute. 5 carbon pent, 6 carbon hex, 7 carbon hept, 8 carbon oct, 9 carbon non, and 10 carbon dec. Although it does not stop over here, it is for 11 carbon, 12 carbon, 13 carbon, and so on. The naming of the alkanes is in this way. Word root is written, word root, and after that there is suffix. Suffix means the word which is written after the word root to indicate a particular type of compound. The word root and the suffix you are going to understand just now by knowing about the different kinds of examples of alkanes. In case of alkanes, the suffix is "ane" with the word root. The general formula is CnH2n plus 2. Now let's see the examples of alkanes. The first alkane is methane. The molecular formula can be derived from the general formula. 1 carbon methane has got, so CnH2n plus 2. We will put the value C1H2 multiplied by 1 plus 2, and it comes to CH4. So the molecular formula is CH4. Now the structural formula is like this. Carbon having all the 4 valencies satisfied with hydrogen. The second homologue of the alkane series is ethane, that is 2 carbons, C2H6. Now as I was telling you about the word root and the suffix of it, you can see over here meth, that denotes 1 carbon, and ane, it denotes that carbon compound have got single bond in it. In case of ethane, eth means 2 carbons and ane means single bond between carbon atoms. To write the structural formula, 2 carbons are there bonded by a single bond, and then here are the hydrogens. So these are the first and the second homologue of the alkane series. Try to write the third and fourth also of alkane series. Third is propane, prop, 3 carbon, ane, single bond between carbon. Structural formula: every carbon should have only 4 bonds. This is propane. C3. H2n means 6 plus 2. It becomes 8. C3H8. Write about butane also. Bute, 4 carbon. Ane, single bond between carbon atoms. C4H10. This is the structural formula of butane. So we have seen in alkanes the 4 homologues of alkanes. All of you try to write the 5th homologue of alkanes also, that is pentane. Alkene. In case of alkene, the word root is written and the suffix is "ene". This is how the naming of the alkene is done. The general formula is CnH2n. The first homologue of alkene will have 2 carbons in it. Try to remember this very nicely, that in case of alkene homologous series, the first member is not methene, the first member is ethene. Because in case of alkene, the carbon atoms have double bond between them. Right? Now let's write the structural formula. C double bond C. It is the first homologue, eth, means it should have 2 carbons in it. Ene, that is the suffix which is telling us that there is a double bond between carbon atoms. So when we write C double bond C, then only 2 valencies are left on carbon. So the valency is satisfied in this way. This is the structural formula of ethene. The molecular formula C2H4. Let's see the second homologue of alkene series having 3 carbons in it. Means the name will be propene. Prop, 3 carbon. Ene, C double bond C. Let's write the structural formula first. C double bond C, C. Now let's write hydrogens. See, carbon having all the 4 valencies. Here this carbon has got 3 valencies satisfied, so only 1 is left. And in this carbon, 2 valencies are satisfied, so 2 are left. This is the structural formula of propene. The molecular formula C3H6. Here you have to keep in your mind that when we are writing propene structure, we are writing the simplest alkene. So carbon will have, these 2 carbons will have a double bond between them. The other carbons will not have another double bond. Only one double bond will be there in this compound. Try to write the next homologues yourself. That means butene and pentene. Alkyne. In case of alkyne, the word root is written and suffix is "-ine". The general formula is CnH2n -2. The first alkyne again will be having 2 carbon atoms in it. So the first alkyne will be ethine. Eth means 2 carbon. Ine means C triple bond C should be there. Let's write the structural formula. C triple bond C, H and H. The molecular formula will be C2H2. Let's see the second homologue. The second homologue will be having 3 carbons in it, means propine. Prop means 3 carbon. Ine means C triple bond C. The structural formula will be, first we will make the chain carbon having triple bond, and then we are going to write the hydrogens in it according to the valency of the particular carbon. So in this carbon only one valency is satisfied, 3 hydrogens will be then bonded to it. In the second carbon, all the 4 valencies are satisfied. There is no need to put hydrogen in it. In the third carbon, 3 valencies are satisfied, so 1 hydrogen will be bonded to it. This will be the structural formula of propine. The molecular formula will be C3H4. Try to write the structural formula of next 2 homologues, that is butane and pentane. Keep it in your mind that you are going to keep the triple bond at the end of the chain only. Because if you will put the triple bond in the middle of the chain, then you have to write the number of that particular carbon also in the naming. So first of all, try to understand the simple ones. So don't write triple bond in the middle of the chain. Instead, in case of butane, write it at the side like this. Write it in this way. Now comes another homologous series, that is alkyl halides. In case of alkyl halides, the naming is done in this way, that the word root is written and the prefix is written for the halogen which is bonded to it. For example, if chlorine is bonded to it, then the prefix chloro is written. If bromine is bonded in the organic compound, then the prefix will be bromo. And after that, the word root is written in the name. If it is iodine, then it is iodo. The general formula for this homologous series is CnH2n plus 1 Cl. So the first homologue of this alkyl chloride series is chloromethane. Chloro is telling us that there is Cl in it, and methane is telling that there is 1 carbon in it. So to write the structural formula, we will write first of all carbon and then the Cl. This is the structural formula of chloromethane. The molecular formula is CH3Cl. The next member of this homologous series is chloroethane. Chloro, Cl, ethane means 2 carbons are there. So first of all, to write the structural formula, we have to write the carbons in it. Then there is this chloro. So we will write chloro. And now we are going to write the hydrogens according to the valencies which are available to us on each carbon. This is the structural formula of chloroethane. The molecular formula is C2H5Cl. Similarly, you can write the next homologues: chloropropane, chlorobutane, etc. on your own. Keep the Cl on one side, otherwise again you have to mention the number of the carbon atom on which the Cl is attached or on which the Cl is bonded. For example, if you take chloropropane, so for chloropropane, let me give you a little hint that 3 carbons will be there, and on this please attach Cl. Otherwise you will have to tell the number of the carbon also on which it is attached. Try to keep it at the side of the chain, at the end of the chain. Now comes alcohol. In case of alcohol, the word root is written and the suffix is all. Right. The general formula is CnH2n plus 2 O. You can also write the general formula in this way: CnH2n plus 1 OH. Because if you want to show the functional group in your formula, then you can write it separately also, OH. The first member of this alcohol series is methanol. Meth, it tells that it has got one carbon. All, it tells us that there is OH group in it. Let's write the structural formula. One carbon. On one carbon there is OH. Now we are going to fill the hydrogens in it. The molecular formula becomes CH3OH. The second member will be ethanol. Ethane tells that there are two carbons in it. All tells that there is OH group. To write the structural formula, two carbons, to that OH is attached, and then hydrogens bonded to it. Molecular formula will be C2H5OH. Try to write the structure of next two members also, that is propanol and butanol. Aldehyde. In case of aldehyde, the naming is done in this way. Word root is written and the suffix is Al. The functional group is C double bond O H, and on the other side of the carbon either hydrogen is bonded or an alkyl group is bonded. It can also be written as CHO. The general formula is CnH2nO. The first member of the aldehyde series is methanol. Methane, one carbon. Aldehyde, this group. So when writing the structural formula, you have to keep this in your mind that C is already there in the functional group. You have to count that C also. So only one carbon in the first member of the aldehyde series. This is the functional group. Now you have to only fill the hydrogens. So hydrogen over here. So the first member of the aldehyde series is HCHO. The second member is ethanol. Ethane means two carbon. Al means CHO group. When we are writing the structural formula, you have to consider that on one carbon you are going to attach the functional group like this. And then on the other carbon you will fill the hydrogens. This is the structural formula of the second member of the aldehyde series, that is ethanol. And the molecular formula, try to write the next members also, that is propanol and butanol. Ketone, word root is written in case of ketone and the suffix is -one. The functional group is C double bond O, which have on both the sides carbon attached. Right? The general formula is CnH2nO. The first member of the ketone series should have 3 carbons in it because on both the sides of the ketonic group the carbon are bonded. So the first member is propenon. Let's see the structural formula of propenon. As I told you, there are 3 carbons in it and the center carbon will have the ketonic group on it. Fill the hydrogens. The molecular formula of ketone is C3H6O. The next member is butanone. Butane means 4 carbons, so 4 carbons. Now fill the hydrogens in it. This is the structural formula of butanone. The molecular formula is C4H8O. Try to write the next 2 homologues also. Pentanone, hexanone. Now a very important question arises that what is the difference between aldehyde and ketone? But in case of aldehyde, to C double bond O group, that is the carbonyl group, on one side hydrogen was bonded, on the other side of the carbonyl group hydrogen or carbon is bonded. But if we consider ketone, then C double bond O group, that is the carbonyl group, on both the sides carbon is bonded. So this is the difference between ketone and aldehyde. Aldehyde is this, ketone is this. In case of aldehyde, it is at the end of the chain. But in case of ketone, it will always be on the second or third or in the middle of the chain. It cannot be at the end of the chain. Carboxylic acid group. Word root and the suffix is oic acid. General formula is CnH2 and O2. The functional group is C double bond O OH. On this side either hydrogen can be bonded or carbon can be bonded. It is written in this way also. The first member of the carboxylic acid series is Methanoic Acid. Common name is formic acid. Methane means 1 carbon. Oic acid means COOH group. When there is 1 carbon, then the functional group itself is having that carbon. In this case, only hydrogen you have to bond with this carbon, and now the structural formula is this. The molecular formula is HCOOH. You can also write it in this way, CH2O2. The second member is ethanoic acid. Ethane means 2 carbons. Oic acid means COOH group. So we are going to write 2 carbons in the structural formula and the carboxylic acid group, and the other carbon we are going to bond hydrogens to it. This is the structural formula of ethanoic acid, which is also known as acetic acid. The molecular formula of ethanoic acid. Similarly, you can write propanoic acid also and butanoic acid also. Now comes the esters. The general formula is CnH2 and O2, and in the naming of the esters, O8 is written, methanoate, propanoate. The ester group is this, C double bond O, O. And on this, any alkyl group can be attached. It can be like this. So CH3, COO, CH3. In case of esters, this part of the ester is named first, while this part of the ester is named later on. The naming is done in this way. Methyl ethanoate. This part which is bonded to oxygen, that is written as prefix, while this part in which there is COO group, that is written as suffix. So the name of this ester is methyl ethanoate. Let's revise it once again. Methyl, the prefix tells us that part of the ester which is bonded to oxygen. So O and CH3. Ethanoate is that part on which the COO group is there. So C double bond O and C. 2 carbons are there of ethane. This is the structure of methyl ethanoate. That is CH3, COO, CH3. Let's see another ester, ethyl ethanoate. Ethyl, that is the prefix, is telling us that part which is bonded to oxygen. So on this part, ethyl is bonded, that means 2 carbons should be there. And on that there is hydrogen also. On the other side, it is ethanoate again. So again there are 2 carbons. This makes the ester group. Now we are going to fill it with hydrogens. This is the structure of ethyl ethanoate. This is the molecular formula of ethyl ethanoate. So I hope you must have understood the nomenclature and the different homologous series today. In the next turn, we are going to take few more topics of the chapter Carbon and its compounds.